Matrix multiplication. When you want to multiply two matrices, it's a bit more complicated than anything we've talked about yet. So the first thing you need to do before you multiply is establish what the dimensions of each of the matrices are to figure out if you can multiply them in the first place. For instance, this first matrix, as we've seen, is a 2 by 3 matrix, and we're multiplying it by, or at least we think we're going to be multiplying it by a 3 by 2 matrix. Now you may say, wait a second, these things aren't the same dimensions, and they're not. One thing to remember when you're doing matrix multiplication is that when you are doing matrix multiplication, the columns of the first matrix have to equal the rows of the second matrix. So what that means is, when you're looking at this, which sounds complicated and awful, it means basically if you do actually write in order these out, you take a look and you look at the columns of the second and you make sure that they correspond, that is, match to the rows. So basically if the inner numbers match, then you're good to go. So when you see this, that means, so AKA, the inner numbers match. So that's how you can establish if you can multiply them. Now, it gets even more fun when we look at what the product is. So the result is a matrix with dimensions that are, ultimate dimensions, rows of first by columns of second. So what this means, and this is very important because otherwise you won't know what you're getting yourself into, if we look at the everything except the inner, that is, if we look at the rows of the first matrix and the columns of the second, that means that we're going to have a result that is a 2 by 2 matrix. So what I'm going to do is give myself a little bit of space to show the operations to make this a little bit easier. But this is going to have 2 by 2 blanks, or a total of 4 blanks. Now, the last thing to remember, when you are actually multiplying, so when you actually multiply, you multiply the rows in the first by the columns of the second. Okay, here's what that looks like. So basically, as you work your way down, then you can figure out what is what. So if you look at the rows, that is 1, 3, negative 5, so you can take this row and multiply it by this column. Now you'll note that if you're looking at this, this is row 1 and this is column 1. So if you take a look at row 1 by column 1, that's going to tell you what goes into row 1, column 1. Now if you think about this carefully, that means row 1 can also get multiplied by column 2, which will tell you row 1, column 2, row 2 by column 1, and so on. You'll see in just a sec what I'm talking about. Now, when you do this, there's a first entry, second, and third entry in this row, and a first, second, and third entry in this. So what you're going to do is you're going to take the first entry in the first row times, it's going to have to multiply at some point, the first entry in the second row, or sorry, in the first column, plus, I probably haven't left myself enough space, but we'll see here in just a sec, then the second times the second, so negative 3 times negative 4, plus negative 5, that is the last, times the last. So we're going to have to make ourselves a little bit more space here, but hey, this is magic land, so we can do that. So what this means is that our matrix is going to get a little bit bigger, but it means that we're going to follow that same pattern going down across rows and down columns, multiplying corresponding entries, and then adding the whole mess together. Okay, let's try another one. So if I wanted to do row 1, column 2, which would be row 1, column 2, then I'm going to take row 1, then 1, negative 3, negative 5, times column 2, which is my negative 2, 5, and 3. So I'm going to take 1, first entry, times first entry, negative 2, plus, always plus, second entry, negative 3 row times second entry, 5, plus last entry times last entry. Now, if you think about this carefully, with very large matrices, this is going to get nightmarish quick, which is part of the reason we resort to technology so quickly. But then to find row 2, column 2, I simply go along row 2, down column 1. So if I want row 1, column 1, I've got this. If I want row 2, column 2, then I take row 2 times column 2. So row 2, 2 times negative 1, column 2 gets a repeat, plus 4 times negative 4, plus 0 times, well, that's an exciting entry, times 0. And last but not least is, of course, row 2, column, I misspoke, I apologize. This should be column 1. Column 1. Let's make sure we get that right. This should actually be column 1 right here. So if I want row 2, column 2, which is actually this one here, row 2, column 2, that's exciting, but pretty much invisible, so let's try a different color. That means what? We're going to take 2 times negative 2 plus 4 times 5 plus 0 times 3. Now, of course, this means that in the end, yes, we've actually got to come up with an answer, and that answer, that is the resultant matrix itself, is going to be a 2 by 2 matrix that's just numbers. So 1 times negative 1, plus 12, plus 0, so that would be 11. Negative 2, negative 15, and negative 15 would be negative 32. Negative 2, negative 16, so that's negative 18. And negative 4, 20, and 0. So negative 4 plus 20 is 16. So let's just double check here. 1 times negative 1, so negative 1 plus 12 is 11 plus 0. Yeah, that looks good. Negative 2, negative 15, and negative 15. Negative 2, negative 16. You can see quickly that if you don't pay attention to your negatives, they will come and they will bite you in the butt. So please be careful. We'll do some more examples in subsequent videos.